Trigonometry, Chapter 5, Trigonometric Identities, Section 1, Fundamental Identities, Video 5, Evaluating Trig Functions Using Identities, Example 3. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. And as the title implies, we are on Example 3, so there are two prior examples if you want to go check them out. All right. So in this one, we are going to start with sine of negative alpha equals a value and also told that tangent is greater than 0. Therefore, we need to find the value of cotangent. Now, there is more than one way to do this one. In fact, there's more than one way to do a lot of them. Let's think about where we're starting and where we want to end. We're starting with sine of negative alpha, but notice that the trig function we're looking for doesn't have the negative on the inside, which means at some point we got to get rid of the negative. Well, we should be able to do that right away. Get the value of sine of alpha using an even-odd identity. Since sine's an odd function, we can capitalize on that. But how are we going to connect sine to cotangent? Well, there's a couple of different paths we can go from sine. We can either use a Pythagorean identity, which connects sine and cosine, or we can use a reciprocal identity, which connects sine and cosecant, neither of which are cotangent. Can we get to cotangent down either of these paths? Well, we can get to cotangent from both of them in one more step. For example, we can get to cotangent in the first path, not directly from cosine, but using both sine and cosine in a quotient identity. Or if we were down the other path and we were at cosecant, there's a Pythagorean identity that connects cosecant and cotangent. So now the question is, which path do we want to choose? Well, if we were to compare the two of them, you would notice that both of them involve a Pythagorean identity. So we can't make our choice on whether or not we want to do that. We have to do that. What it boils down to is whether or not we want to use a quotient identity or a reciprocal identity. And given the choice between the two, the reciprocal identity is easier because we just have to turn something upside down. For a quotient identity, we have to stack things on top of each other and clean that up. Not that it's difficult, but I think the reciprocal identity is easier to pull off than the quotient identity. And so with that said, I am going to choose the path that uses the reciprocal identity. So my path is going to look something like this. Use an even-odd function to get sine of alpha, use a reciprocal function to get the cosecant of alpha, and then Pythagorean identity to get the cotangent of alpha. All right, so let's give it a whirl. Let's start with, let's put this in black. I don't know why, that just sounds good. Let's start with taking sine of negative alpha and figuring out what to do with it. We know sine of negative alpha is 5 squared root of 26 over 26. But what does this imply about sine of alpha? Well, being an odd function, if you're an odd function, that means opposite inputs produce opposite outputs. Since alpha and negative alpha are opposite inputs, then the output should also be equal, meaning the sine of alpha is going to be negative 5 squared root of 26 over 26. All right, so there's our first move. We got the value of sine. Let's highlight that to make it a little bit easier to find. And here it is. Sine of alpha is equal to that. All right, what's our next move? Our next move, if we go back a slide, was to use a reciprocal identity to get cosecant of alpha. So now, cosecant of alpha is the reciprocal of sine of alpha, which is going to be this fraction turned upside down. If we turn it upside down, we'll get negative 5. No, we won't. Let's erase that. We will get negative 26 over 5 squared root of 26. But let's rationalize that denominator by multiplying both sides by the square root of 26. And what will that give us? That will give us negative 26 squared root of 26 over 5 times 26. But the 26 cancels, 26's cancel, and we get cosecant of alpha is equal to negative square root of 26 over 5. Okay, another good one to highlight. Thought that a highlight was a little bit thicker, but that's fine. All right, so what was our move after getting cosecant? Remember, our destination is cotangent. And when you're playing these identity games, it always helps to ask yourself, what's our final destination? Since our final destination is cotangent, and we currently know cosecant, we can use a reciprocal identity. We had already decided that, excuse me, a Pythagorean identity. We had already decided that here. So let's go do that. We know, let's see. Oh, that was a pen. No wonder it wasn't highlighting well. All right, so we currently have cosecant of alpha equals negative square root of 26 over 5. Cosecant of alpha is negative square root of 26 over 5. Now we want to find cotangent of alpha, and we're going to use a Pythagorean identity to get it. Pythagorean identity is 1 plus cotangent squared of alpha equals cosecant squared of alpha. We don't know cotangent yet, so that's going to stay the same. However, we do know cosecant, and we just need to square it to substitute it into the Pythagorean identity. If we square root both sides of this fraction, first off, it comes out positive. Secondly, the 26 on top becomes just a 26, or rather the square root of 26 on top upon getting squared becomes 26. And the 5 on the bottom upon getting squared becomes 25. And now we just have to subtract 1 from both sides to get cotangent of alpha equals 26 minus 25, but minus 1. But that's 26 25ths minus 25 25ths, which is just 1 25th. And now we simply have to square root both sides. Okay, well, that's pretty easy. If we square root both sides, 1 second. I'm not sure what just happened there, but everything seems to still be recording. If we square root both sides, we get cotangent of alpha equals plus or minus the square root of 1 25th, which is plus or minus 1/5. But can we narrow it down to either positive or negative? And the answer is yes, because we know that tangent is greater than 0, which means cotangent is also greater than 0 because we reciprocate that way. We could have also chosen quadrant 3 early on because we knew at this point that sine was negative. And at this point, we knew cosecant was also negative. Well, sine and cosecant are always the same sign. And tangent is positive. So that combination, if we go to our little gimmick for finding a quadrant, where is sine negative? Well, not quadrant 1 and not quadrant 2. And where is tangent positive? Well, not quadrant 4. So that puts us in quadrant 3. So we know that cotangent is also going to be negative. Excuse me, positive. So it does end up being just the 1/5. It's really kind of a roundabout way to get there, but the algebraic skills embedded in going from one trig function to another are going to prove very fruitful, not only in this course, but in future courses.